Okay, today we're going to look at the sine law and ways we can solve non-right angle triangles. So in Math 10, you learned how to use sine, cosine, tangent on triangles that had a right angle of 90 degrees. But now you could be faced with problems where you don't have that right angle anymore, and we have to know how to deal with that as well. Okay, for this lesson and the one for next week, just make sure that your calculators are in degree mode, not radians. So just make sure you know how to change that. And let's go talk about the sine law. So you have a picture provided. It's a scalene triangle in quadrant 1. Use the triangle ADC to write an expression for h. So there's that height, that altitude, in terms of b, and a trigonometric ratio of a. So I need to figure out somehow how to relate the side length b, the side length h, and angle a. Now if I look at this triangle, the right angle is in the corner where d is. So according to angle a, h is what we would call the opposite, and b is the hypotenuse. Now from before, you know that ratio is the sine ratio. So you could write the sine of angle A is equal to h divided by b. Now that expression is not equal to h yet, like I was asked to do, so we need to rearrange this. And if you do that, you're going to find that h is equal to b sine A. Okay, so there's one part of this, so that's important. The other part, we have another right angle triangle on the other side of that altitude. So we're going to do the same thing on the other side of that triangle with the other couple of items. So we're going to try to write an expression for h in terms of the angle b and a this time. So same idea. The option that relates those two sides is going to be sine once again. So the sine of b is equal to that height, like we said before, h, divided by the hypotenuse of a, and I think you can see where we're going with this. We're going to work with it to make it so it says h equals again. So rearrange that. H is going to be equal to a sine b. Now, if both things in those boxes, the blue and the purple one, if they're both equal to h, then whatever they're equal to has to be equal to each other. Okay, so that means now that b sine a is going to be equal to a sine b. Okay. Now what you can do is you can leave it like this. This is one format that could work. Or you could write them as fractions and match up the angles and the sides together. So remember that capital letters, so the sine of a, that's the sine of angle a. The lowercase a is a side length. That's totally different. Okay. So if I divided both sides by a and both sides by b, essentially what will happen is the b's will cancel on the left, the a's will cancel on the right, and I've got my angles and sides matched up together. So therefore, you could say that the sine of angle A divided by the side length opposite to that angle, remember they're always across from each other, that's equal to sine B over B. And this right here is what we're going to call the sine law. And we're going to use this for those non-right angle triangles. Okay, if you were to rotate this triangle and place angle B or C at the origin, so just turn the picture sideways, you can come up with the same ratios for the other one. So you could say also, if you like, sine of angle C over side length C. These all three are going to be equal to each other depending on which way your triangle is rotated. So that sine law you could write even upside down, placing those side lengths on the top with the sine of their angles on the bottom. It means the same thing. And you can use this to solve for missing angles and sides in non-right triangles. Now this equation uses sets of angles and corresponding sides to build ratios. The sine law is useful, or it can be used if you have or can get one complete set of angles and sides. And on the back page, we'll do a couple of examples talking about this. So the first one asks us just to find the length of side D rounded to the nearest tenth. So we are trying to locate the measurement of this side length. Now, in order to use the sine law, we do need to have a pair of information. So we need one angle and one side. And that information always needs to be opposite. Okay, so in purple, I know an angle of 18. I know its corresponding side across from it is 6.5. Now, the other piece of information that I need is another side angle pair. So I have an angle of 46. The side I'm trying to solve for is its corresponding. So out of those four pieces of information, I know three of them, which means I can solve for the missing one. So our sine law formula then, sine of A over A equals the sine of b over b. Now we can start filling things in. The angles are your capital letters, so we'll say that the sine of 18 degrees needs to get divided by its opposite side, which is 6.5, and that's meters. Units don't really make a difference here. They'll work out in the end to be exactly what we need them to be. So the sine of our other angle, sine 46, over the side length we need to find. Now, you're free to get rid of the fractions, manipulate however you choose to. Since this is a proportionate ratio, I've got two fractions equal to each other. You can use a cross multiply and division trick. So take the two quantities that are diagonal from each other that you actually have values for. I know this is 6.5 meters. I can figure out what the sine of 46 degrees is on my calculator. So I'm going to multiply those two quantities together. So 6.5, multiply it with sine 46, making sure you're in degree mode. Press enter. Once you take care of the cross product, divide by the remaining quantity. So I'm going to divide this by the sine of 18 degrees, and that will take me right to my measurement for that unknown side. So this means that D is going to be equal to the nearest tenth, 15.1, and that's meters. Okay, so there's your side length. So the sine law is very, very nice to use as long as you remember that you need opposite side angle pairs. Okay, so there's my 15.1 meters. Now the one underneath, this next example asks us to solve the triangle. And if you're asked to solve a triangle, you need to find all three sides and all three angles. However you choose to do that doesn't matter. So if I look at this one, I only really have one angle. Now I know that the sum of all three angles in a triangle has to be 180. So right now I don't have enough information to find those. I can't use inverse sine, cosine, and tangent like I would have for a right angle triangle. I would have to use some variation of the sine law here because I don't see a 90-degree angle. I can't use those primary ratios in the way I would have in Math 10. So we need to figure out what we have and what we can find. So I know I've got a side angle pair circled in purple. I know I have a side of 13, which means if I could circle this angle, I have enough information here to find out what angle B is. So let's go ahead and do that. So we're going to say the sine of B over my 13 meters, so that's one pair. That needs to be equal to the sine of 46 degrees over 9.5. Okay, that's my other pair. And remember, if the pairs are opposite, always a side and an angle. Now again, I'm looking for that unknown quantity of B, so I'm going to do the cross multiply and divide. I'm going to go in this direction this time. So I'm going to take 13, multiply it by sine 46. Hit enter. Then I'm going to divide that by 9.5. And I'm going to get a weird decimal. Now remember, that's not my final answer. That's actually what sine B is. So 0.9844, we'll say. We'll take 4 decimals. Now in order to get B, now I can use that inverse sine ratio. I want to basically get rid of sine. So that means B is going to be equal to the inverse sine of that decimal. Okay, that means angle B, angle B is equal to, so we can hit second sine on our calculator, put in the decimal 0.9844. My angle to the nearest whole degree is where we usually round angles to, so that's going to give me 80 degrees. Now I know I used the rounded version. Now if I were to use this whole decimal, second sine, so that's 0.9843597,268. It really doesn't make a whole bunch of difference. I'm still going to be rounding that to the nearest whole degree. It's still going to be 80 anyways. Doesn't really affect my answer too much. Okay, so that angle B is going to be 80 degrees. Okay, now that I know two angles, I actually have enough to find the third. So we're going to go do that for angle A. So now I can say that angle A is equal to 180 degrees. So the total sum of all three in that triangle, minus 80 minus 46. That means that angle A is going to be 54 degrees. So now I know that other angle that I was missing is 54 degrees. I've got 2 out of the 3 pieces of information. The only thing we don't know about this triangle is that missing side length, BC. Now, I do know that angle. So now I have enough information to do my other side angle pair. So one of those pairs has to be sine 54 over BC. Now the other pair can be any of the other 2 that you want. So you could use the ones in purple, the 46 and the 9.5. You could use the 13 and angle B, that 80 degrees. I'm going to use the purple ones because I was given both of those dimensions, which means I didn't have to do any calculations to get them. Now I know it's kind of impossible here to use something that you were given to find everything. So just be very careful when you're going to do these. Take your time because there's so many steps here. I'm just going to try to use the information provided. So I'm going to use sine 46. Let's change that color. So that's sine 46 over 9.5. And we'll go find out what BC is. Now again, I'm going to use that cross multiply and divide. So always start with the 2 items that you know that are diagonally across. I can't go the other way because I don't really know what BC is yet. So I'm going to start with the other 2. Go 9.5, multiply it by sine 54, hit enter. And I'm going to divide that by sine 46. Okay, so now I know that BC, its length to the nearest tenth is usually where sides go. So that'll be 10.7, I think it's meters. Yep. As you can see, even in the picture, they give us a side length to the nearest tenth. So just for the future, side lengths usually go to nearest tenth. Okay, so sides usually to the nearest tenth, and angles usually nearest degree. Unless it's otherwise stated that you have to go to the nearest hundredth or something. Usually this is what happens. Okay, so the sine law can do a lot for you. It can find things without using those primary trig ratios. Just remember, you can always take the sum of all 3 angles to be 180, so you could find out any missing one should you have 2 of the 3. And that's essentially the sine law. So when we do this again, we'll talk about the cosine law and how I have another way to deal with those non-right angle triangles.